Alright, so we're going to be trying this problem over here, which says that if you've got a line which is a tangent to a logarithmic line over here, logarithmic curve I should say, natural log of 3x minus 1, then we want to find the value of n over here, which is the gradient to our tangent. So just saying the word gradient itself is probably a hint that we need the derivative function. So just to differentiate between these two rules over here, first of all, I'm just going to say that we let f of x equal to ln 3x minus 1. So this is going to be a tick active problem. There's going to be a few complicated calculations to go through. So first of all, we're going to try to work out the tangent line function, and we're just going to go through the mathematics of what's happening behind here. So on our calculator page, not that one, it would be the CAS page. We want to find the derivative of f of x. So first of all, since we know that we're going to be using this function quite a few times, let's just define f of x as ln 3x minus 1. Okay, and if we need to work the derivative quite often, it also pays off to also define another function. Let's say g of x equal to the derivative of f. So just keep in mind that whenever we reference g over here, we're referring to the derivative f dash. Okay, so of course, if I write g of x over here, it's immediately clear that this rule, well, this expression over here is the rule for the gradient function f dash. So let's just write that down first, because it's pretty useful information. So f dash of x is equal to 3 on 3x minus 1. Okay. Alright, now that we have these two over here, the question prompts us to say that we need the value of n. Okay, so what we're going to say is, let's start from the beginning. The gradient of the tangent is n, and we know that this n value over here should be equal to our gradient function at some value of x. So what we're trying to find over here is find value of x in terms of n. So we're finding the x coordinate at which this tangent is occurring. Okay, so solving for this is going to see what it gives us actually. So I'm going to take 3x minus 1 to the other side, take n to the right. So something like this. And rearranging to make x itself, we're going to get 1/3 over 1 plus 3 on n. Okay. Or alternatively, you can say 1/3 plus 1 on n. Doesn't make too much difference, but I think this one, changing it to this latter form over here, would make our lives just a little bit easier later. And the idea here is that we want to find the point of intersection where this tangent and the curve f of x occur. So if you want to find a point, of course, you can just sub this back into f. Okay, and we're going to let the cats do a bit of work over here. I mean, actually, you know what? Let's do this by hand. Could be fun. So we have ln of 3 multiplied by 1/3 plus 1 on n minus 1. So over here we get 1 and 1 over here. So let's just cross these out, okay? So we have this term over here, this term here over here. They're going to cancel out once you expand this bracket. So what we're left with is simply 3 times 1 on n. Sorry, the natural log of 3 on n. Okay, So you got your x coordinate, you got your y coordinate. So you know that the point over here is going to be at 1/3 plus 1 on n, comma, natural log of 3 on n. Okay, so remember that if you have a point and you also have your gradient, you can find out the equation of your line. So for the equation of tangent, you need two things, just to recap. So one is your point, which we just got, and the other one is your gradient, which was n. That's given to us. So let's try to work out what we have over here. Now if we put it in the form of y minus y1 equal to m x minus x1, this is normally how we find the equation of tangent. And now we're just going to work backwards a bit. So have y minus our y coordinate, which was ln 3 on n, equal to n multiplied by x minus, let's just scroll up. So minus 1/3 plus 1 on n. Okay. So if you want to find the equation of your tangent with y as your subject, then this would mean you have nx, which is the same as what we had before, and expanding this over here. So let's do this very carefully. So n multiplied by negative 1/3 will give us minus n on 3. N multiplied by negative 1, because minus 1 on n, it's going to give us minus n on n, or minus 1. And we're going to add or take this logarithm over here to the other side. So we have this. Okay. And referencing the question 4, we know that the tangent is nx minus 1. This is the equation of the tangent. So if these two have to be the same as each other, so if both of these are the equation of your tangent, yt, then doesn't this mean that the mx value has to be the same? So it looks like nx and nx over here, that's okay. And what you need to line up is just the constant, or in other words, the c term of mx plus c. So the equation that we can form here from just equating two parts which are underlined in red is going to be negative 1 must equal to all of this over here, because that's the constant component which we just found. Okay, so it looks kind of complicated, but of course you can just cancel these two out. You can add 1 to both sides, or well, whatever you want. I mean, if you have negative 1 on both sides, you can just cancel them out. Yeah, so if you add 1 on both sides, these both turn into 0. And we're really solving for this. 0 is equal to negative n on 3 plus natural log of 3 on n. A little bit complicated to do by hand, so this is where we can use technology to help us out. So moving back to our CAS, we can say we have the solve function to help us out. So 0 is equal to negative n on 3 plus natural log of 3 on n. We're solving for n, and so going back to here, I pressed enter once, doesn't quite give us a correct value here, so pressing Control Enter will give us plausible n value of 1.70143. Yeah, seems about right. Okay, we'll just approximate this to we'll say 3 decimal places. Just put this video over here. Alright, so this actually works quite well. Now if we graph it out, we'll just see how plausible our answer is. So first of all, we had the curve natural log of 3x minus 1, or f of x, and we know that the curve, or the tangent to this curve, should be negative 1.701 times x minus 1. Seems like it works out quite nicely graphically. Now, what we're going to be doing from here is there a shorter way of doing this? What we just did took quite a long time. So what I'm going to propose here is just down in this little space, we can work it out. Now, first of all, let's think about the tangent line function. So on your CAS, you'll realize that there's a function. Okay, so I'm just going to draw a line here. I'm going to move on to a new kind of step. So for the tangent line function, this function over here, if you're given the curve f of x, so this was what was it, ln 3x minus 1, and you tell the CAS what variable you have and what else, what x value. So in other words, x coordinate in this case. So we did find that out a bit of working out, and that was 1/3 plus 1 on n. Let's just make sure that's right. Yep, so we're just looking at this one over here. 1/3 plus 1 on n. So if you give the CAS everything, well, not everything, just these 3 features, then this spits out the equation of your tangent. So over here is just equation of tangent, or rather, to be more precise, the expression of your tangent, or the rule of your tangent. So working backwards a bit over here, what we can say is that this expression of your tangent, or the rule of your tangent, has to be in x minus 1. And we can tell the CAS, well, what possible values of n will this be true? And another way of saying that in CAS language is using the solve function. So over here, solving for the tangent line function, so using the book icon and then pressing T, I'm just going to scroll down to tangent line. Okay, so we defined our curve, our logarithmic curve as f of x, comma x, that's the variable that we're using, and the coordinate was 1/3, so just use brackets here. Actually, you know what, let's use a fraction. So 1/3 plus 1 on n. Okay, and this all has to equal to n times x minus 1. So just make sure that your n and x over here are separated, since they are different variables. And we're going to solve for, no, not x, solving for n. And just move back a step. Just press Control Enter here for an approximate answer. And the CAS does work out the exact same n value over here. So if you solve using this kind of notation, now the tangent line function should spit out your rule, but you're given your rule. So this means that to work backwards, you can use the solve function to say that the tangent line function with these 3 characteristics should equal to the rule that we're given over here, solve for n, give us the exact same answer.